My name is Lakshmi. My topic is cumulative distributive function. Here is the introduction about the cumulative distribution function. The cumulative distribution function is a fundamental concept in a probability theory. It provides a way to describe the probability that a random variable takes on a value less than or equal to a specific point. Understanding the cumulative distributive function is crucial for statistical analysis and interpretation of the data distributions. Here is a definition about the cumulative distributive function. The cumulative distribution function of a random variable x is defined as f of x is equals to p of x less than or equal to small x. This function gives that the random variable x is less than or equal to a particular value x. Cumulative distribution function can be applied to both discrete and continuous random variables with slight variations in a calculation. Here there are the graphs between the cumulative distribution function and the Poisson distribution function. The definition of the cumulative distribution function is the cumulative distribution function of a random variable x is defined as f of x is equals to p of x is less than or equals to x. The properties of a cumulative distribution function. Cumulative distribution function is a non-decreasing function, meaning it does not decreases as x increases. If the value of x increases, the cumulative distribution function value does not decreases. The limit of the cumulative distribution function are defined between 0 and 1, where f of minus infinity is equals to 0 and f of infinity is equals to 1. Cumulative distribution function is right continuous, which means it approaches its limit from the left hand side. The properties of the cumulative distribution function: limit extends to minus infinity, f of x is equals to 0, limit extends to minus plus infinity, f of x is equals to 1. If a is less than b, then f of e less than or equal to f of b for any real numbers a and b. These are the properties of cumulative distribution function. Cumulative distribution function for discrete random variables. For discrete random variables, the cumulative distribution function is computed by summing the probabilities of all outcomes up to x. It is a step function where each step corresponds to a specific outcome. Discrete cumulative distribution function provides a clear visualization of the properties for different values of the random variable. Here there is a graph. Values taken on the x-axis are x1, x2, x3, and so on x up to xn. For f of x, x is equals to 0. For x is less than x1. On y-axis, the graph is of px of x1, p of x2, up to p of xk. For limit extends to infinity, f of x is equals to 1. As we know the properties of the cumulative distribution function, limit extends to plus infinity, f of x, then it is equal to 1. Limit extends to minus infinity, then f of x is equals to 0. Cumulative distribution function for continuous random variables. For continuous random variables, the cumulative distribution function is obtained by integrating the probability density function. Poisson distribution. Probability density function. The cumulative distribution function is a smooth curve that reflects the cumulative probabilities up to the given value. It allows for easy calculation of the probabilities over intervals by subtracting the cumulative distribution values. The cumulative distribution function is a smooth curve that reflects the cumulative probabilities up to given value. It allows for easy calculation of probabilities over intervals by subtracting CDF values, means continuous random variables, cumulative distribution values. Here you can see the probability density function. The graphical representation of the cumulative distribution function. Graphs of cumulative distribution functions show how probabilities accumulate as value increase. A cumulative distribution function graph typically starts at 0, 0 and ends at infinity, 1, which illustrating the total probability. The steepness of the curve indicates the likelihood of values occurring within certain ranges. Here is a graph between x values of x taken from 0 to 7 and the probability from 0.0 to 1.0 with a difference 0.2. Here the black line represents the data and the red line represents the prediction. Applications of the cumulative distribution function. Cumulative distribution functions are widely used in the statistics for hypothesis testing and confidence interval estimation. They are essential in risk assessment and decision making in fields such as finance and engineering. Cumulative distribution functions also play a critical role in simulations and modeling of random processes. The relation between cumulative distribution function and probability density function. For continuous random variables, the probability density function is the derivative of the cumulative distribution function. Conversely, the cumulative distribution function can be obtained by integrating the Poisson density function. Understanding this relationship helps in transitioning between different representations of a probability. These are the relations between the cumulative distribution function and probability density function. Cumulative distribution function in multivariate distributions. Cumulative distribution functions can be extended to multiple random variables reflecting joint probabilities. The joint cumulative distribution function provides the probability that each of the variables falls within specified ranges. This extension is crucial for understanding the behavior of correlated random variables. Here there is a sum that fxy from x comma y limits are from minus infinity to x and plus minus infinity to y. F for xy that from lambda comma mu, derivation of lambda into derivation of the mu. After solving, the solution is 1 by 3 into x square minus 1 plus 2x by y exponent minus xy minus 2 by y exponent minus y plus 2 by y square exponent minus xy minus 2 by y square exponent minus y. Conclusion and further study. The cumulative distribution function is vital for analyzing random variables and their distributions. The strong grasp of cumulative distribution function enhances statistical literacy and data interpretation skills. Further study into specific applications and numerical methods can depend understanding of CDFs. This layout provides a structural overview of cumulative distribution functions covering essential aspects and encouraging further cumulative distribution functions. Here is a definition. The cumulative distribution functions f of x for a continuous x is defined for every x by f of x is equals to p of x less than or equal to x for limits from minus infinity to x f of y comma dy. For each x, f of x is the area of under the density curve to the left of the x. Thank you.